everyone. So today we are in the latest video of this NEMA controller series, in which basically we explain how we could control or connect these NEMA controllers to the motors. So we were already talking on previous videos that I will put you on top of the screen regarding to this previous controller that it has the driver already integrated, and the standalone could drive NEMA17. So today we are going to talk about this other driver that basically can control a specific motor driver, okay, with some signals. Basically, this could do it as well, but this is a bit more expensive and makes no sense if you are going to use external driver to buy this one. I will go with this one. So in case you find this video or the previous one interesting, so please subscribe, give it a like, and also I will put you here my Instagram in a way that you can subscribe as well there. I am posting time to time, more often than in YouTube, mechanical things, electronic things, so feel free to subscribe, as said. So we are going to start with this video. The first part, we are going to talk about what we need, okay, to use this specific motor controller. So basically, we are going to put aside a bit this other controller and focus on this specific. So basically, this controller has no driver, okay, it's the ZK SMC01, as you can see here. It has no driver for the motor, it's only providing the signals needed to the specific driver to work. So what we will need is the controller itself. We are gonna need the one driver that I will explain you later why here I have two. With this, in this way we have a bit more flexibility, because these controllers, this one also, can only work till 30 volts. And some big motors needs or works better with higher voltages like 36. So this is going to be one of the advantages. And the other advantage is that this driver can only provide 4 amps, and with this one we could drive a motor driver in a way that we can provide 10 amps, whatever the driver is rated. So this is another advantage of this controller. At the end, it depends of your application. As I said, if you need a small motor, this will work more than enough. If you need a big motor, higher performance, I would recommend to go with this option. So, as I said, we need the controller, we need the driver, we need the motor. In this case, I am using NEMA17 because just to fit everything on the table, and the power supply that we show how to connect it to the main the last video. So you can go to it to see it again. So basically this is what we need for sure. We need different cables. The controller is coming with this cable already that you can use it to connect it directly to the driver. If you need to extend it, you can extend it as well. I will probably put you the part number of this connector on the screen, in a way that if you can put or you want to put specific cables, you can also do it, crimping it. So with this cable, the power cable and the cable for the motor, it's more than enough to make this work. So now that we know what we need, I will prepare a bit the setup, because I would like to show you first the differences between these two drivers and why one is working and the other one not. And later on we are gonna go to how to connect everything and make it work. So let me prepare the setup and we can continue. Okay, so we have the drivers here. Basically, as you can see, the connections are not quite the same, okay? They are two different drivers, they can do the same. So for this NEMA17 will work perfectly both. For sure, maybe one can give more current. Right now I don't have it in mind. Yeah, but basically you can see here that the peak current provided by this one is 2.2 and by this one is 3.5. So as I said, one can provide a bit more current, but beside of that, there are not big difference, okay? They are not high-end drivers, but for this purpose they will work. It's extrapolated, can be extrapolated to every driver. So which differences do we have between the drivers? So basically the motor signals remain the same, no problems here, so no issue. As said, we already learned on the second video how to connect the motor to the signals, we are gonna repeat it again, but basically the two windings and the input power, okay, for the motor, in this case is isolated. So the voltage that we have on the motor is not the voltage that we have on the signals. This is important to understand. And but what we can see difference is the signals, okay? In this driver, we can see that we can access directly to each of the positive and negative signals on the controller signals, okay? As you can see, we have enabled negative, positive, negative, positive for direction and negative, positive for pulse. And as you can see, there is a drawing here that is basically showing a optocoupler, okay? What optocoupler means is that, let's say, if we put this in this direction, okay, so we have one side here that this is the LED. It's an LED that basically is emitting light when we power it, and on this side we see this like arrow that it is photodiode. It's infrared diode or whatever we want to collect. So basically what it is happening here is that we are isolating the voltage, right, or the circuits. Means that when we input here voltage on this side and the LED is lighting, the LED is sending light to the infrared receiver or the photodiode, and this photodiode, let's call it in this way, is generating voltage on the right side. So without physical connection, because as I say, there is only two LEDs, we can have the voltage that we have here replicated on this side. So basically what we achieve is having isolation. But just wanted to explain you a bit how this works. What it is important here is that we have access to the both signals, positive and negative. On this one, we see that the shape is quite similar, the motor connections, they are quite similar, but the controller or the input signals, they are not equal. So we can see that the input signals, they are not equal. So basically we see here that we have enable, it's fine. Opto, this opto is new, direction, pulse, and some two LEDs to check that everything is fine. So basically, what problem do we have here? We cannot control directly the LED with the minus and plus, so we have some limitations regarding how to connect the driver, because the opto is the positive, okay, for all the LEDs, they are connected together. So we are gonna switch to the laptop, and I will show you that unfortunately with this driver that we have here, that it is only providing positive signals, let's say, we cannot control this kind of drivers, and we need this kind of drivers that they have the two polarities, negative and positive, accessible. So let's go to the laptop, and I am going to explain you what is the problem. Okay, so here we have the two drivers that we had on the table. So this is the first one, the basic one, and this is the second one, that this is the one that it is working on the controller. And here we can see that we have the controller, okay? So here is the controller, here is the driver 1, and here we have the driver 2. So basically we need to understand the differences in order to know if we can connect them or not. So if we see the controller, we have these signals, enable, direction, pulse, that they will be positive, right? And we have the GND, that it will be the ground. So basically what we can provide here is a pulse that it will drive each of the drivers. So now if we go to the drivers and we go to the one that it is not working, so this one, basically we can see that we have the opto, that it is the input for the LED, as you can see here. So it's the positive, and here is the negative. So here we can put a pulse. This pulse can be introduced here, but the problem that we have is that, as you can see, we have this pulse distribute through all of the optocouplers in a way that we cannot control each of them. We cannot connect them, because if we put the positive here, let me change the color. If we put the positive here on the direction, on the pulse, on the enable, we are introducing here the positive pulse on each of the signals, and basically this will not work because the diode, this diode here, is not being polarized properly. So basically what we have here is this one, and this is always positive, this is always negative. So important when you select a driver that you can input the positive voltage that we see here independently to each of the optocouplers. So why with this one is working on the one on the left side? So basically because the connection will be pulse positive, direction positive, enable positive. So we can put the pulses on each of the optocouplers separately, and here it is sending the positive and here it is going the negative, and the pulses or the negative signals, they need to be connected together, and this is not a problem here because basically we can connect them in this way and it will work perfectly. So this is the main reason why this driver is not working, this one, and this one is working. So take care, because at the beginning I bought, or I had here at home, this driver, and I noticed that it was not working and I needed to buy this one. That means more money if you already had one. So please take a look. So we will continue showing you a bit more in detail how we can connect everything together and making it work. So continuing with the video, we already have here everything that we need in order to connect the controller to the driver and the power supply. So we are going to do it step by step, so you are not going to miss anything. So let's take a look. First, we are going to go to the motor. So basically we need to, let's say, power the driver probably. So we need to have the VCC in this connection here, as you can see, and we need to connect here the ground, okay, of the driver. Consider if you are using, in this case I am going to use the same power supply, but if you are using two power supplies, one for the motor or one for the driver and one for the controller, because remind, only maximum 30 volts, the grounds can be separated, so you don't need to have them together. So we are powering the driver. Basically we are connecting it to the power supply, to the minus and plus. It's a bit hard the first time. So here it's the minus, it's 12 volts, and here is the plus that was never used, that's why it's a bit hard. So we have the power supply that we have here with the main and the 12 volts in this case, and the driver already powered. Right now what we are going to do is to connect the motor. So in this case my motor has a connector, so can be separated, so we can connect it here. Not all the motors has this connector, but if you have it, it's just good enough. And we have the 4 cables. So basically the red one is the B minus, so we are going to connect it here. Let me do it in this way, exactly. So the B minus is going to the B minus. As we were already discussing, it's important that you take a look to the datasheet of your motor, or otherwise there is another way. You can measure with the polymeter, and some of the windings, the ones that they are paired, A plus, A minus, they will have continuity. So you can already check them and try an error, so it's not so complicated. The green one is B plus, so we are going to connect it to B plus in this case. And as said, you can always figure out the winding of these motors, is not so complicated. The blue one is the A minus, so we are going to connect it here like this. Let's open it properly, the connector. I really like this kind of connectors. You can also extract it, but to you to see, I think it's better if I do it in this way. And the A plus, that we are going to connect it here as well. Okay, so easy. We have the motor already connected with the power supply. So now what we need to connect is the controller, and the controller comes with this connector that you can see here, that as said, I will put you the part number of this connector over here, in a way that if you can, or if you want to crimp some specific cables for this, you can do it. So as you can see now, we have the driver with the GND enabled direction pulse DC plus DC minus. So first thing we are going to do is to connect the DC plus DC minus. As you can see here, they are these two that they are on this extreme, so we can strip them, and the extreme one is DC plus, so this one is DC plus, so we are going to connect it to the DC plus of the power supply, as you can see here. Perfect. And with the DC minus that you can see here, DC minus, we are going to connect it to GND. It's a bit annoying that it has no GND, it's a bit confusing, but it is okay. So we have the controller power, so this we can close it already, and now we need only to connect the signals, okay? So we have GND, enable, direction, and pulse. The first thing we are going to connect is the GND, because we need to do something on the driver side that basically with small cables you need to connect the grounds of the LEDs, minus, 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 to have them together, because they are not internally connected. So let me open the screws, and we are going to connect them all together. So basically we put one cable here, and we short circuit with the another minus, and at the same time we use another small cable like this one, and we put it in the same hole. Okay, so let me check if these both are grabbed. So I said both at the same time. So as you can see, this does not work. Let me open it again and put it in this way. Okay, so let's open it well, like this. Okay, now both are tied together, as you can see. So minus and minus, they are short circuit now. And the latest minus, that for the moment we are going to open it, insert it, but we need also to insert at the same time this GND, that in this case is this cable that you can see here. Okay, the GND that it is close to the signals is the GND for the driver. So we are gonna strip it a bit and put it together with these cables that we place here in the latest one, in a way that they will be connected together. Minus, 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 and minus, GND. Okay, and now two things, or three in this case, left. Connect the enable, direction, and pulse. So if we follow the traces, the first one that we have here is the enable. So basically we are going to open the screw, put it inside, and close it. As you can see, it's already grabbed. Enable, direction, okay. So let's put the next one, direction, like this. And the latest one that you can see, it's here, that it is pulse. So pulse, we are gonna put it on the positive side of pulse, as said. And let me finish this, and I am going to repeat it. We need to connect the pulse, direction, and enable to the positive signals, and the GND all together to the minus, 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 okay? So we have already connected the motor, and right now what we are going to do is to switch on the power supply, that we are gonna put it here, and you are going to see that it is working perfectly. So let me plug the power supply, and also put here a flag in the motor in a way that we can see that everything is working. Okay, so basically now this is working. As you can see, the controller is working, the driver is also connected, and it has here an internal LED that it is showing that it is everything fine. So the only thing we will need to check is that we have the micro step in like we defined on the first video as expected. So basically we can go to the configuration, push the encoder, and go to the number 9. So basically we see here 160, that means multiply by 10, as we explained, 1600. So we are gonna keep it like it is. And if we go to the driver here, we go to this table, okay, we need to put the 1600, so it's the 8, and required S1 off, S2 on, y S3 off. So we are gonna take a look. We have it as it is here, okay, so it's fine. So let's have a try. As you can see, the motor is working perfectly in both directions. So that's basically all what you need to connect this motor controller that has no driver to the driver and the motor, and also to the power supply, in order to have a NEMA motor working. So I hope you enjoyed this video. Please, if you find it interesting, subscribe, give it a like, and also you can check my Instagram, and hope you see you in the next one.